Questions from 1 to 7 are already covered in paper 1 part 2 video. You can check them there. Starting from question 8, the diagram shows a solid triangular prism on a horizontal floor. The face in contact with the floor is a rectangle of width 2 meters. The pressure on the floor due to the prism is 80 newtons per meter square. The force exerted by the prism on the floor is 720 newtons. Work out the length of the prism. So this face, which looks like a rectangle, is in contact with the floor and has got the dimensions of 2 meters width and a length of unknown value. So let that length be x. So the area of this rectangular face will be now length times width, which is 2x. We have already got the pressure and force, and the formula to find pressure is given as force over area. So using this formula and substituting these values here, I will write, so the pressure is 80 and the force is 720 over the area is 2x. To find x, we need to make it as a subject of our equation. So I times with 2x on both sides. Now the left side will be 2x times 80. So the double of 80 is 160. 160x equals 720. 2x cancels out. And then we have 160x is 720. You can get rid of 160 by dividing them on both sides. So we have x equals 720 over 160. Zeros cancel out. We can simplify it further by dividing with 4 for both numerator and denominator. So you have 4 goes in 7 once. We have 3 as a remainder, 32. 4 goes in 32, 8 times. And 4 goes in 16, 4 times. We can simplify it further by dividing with 2. So half of 18 is 9. Half of 4 is 2. So now we have 9 over 2. So what is half of 9? So 9 over 2 is half of 9, which is 4.5. So the answer for the missing length for the prism rectangular face is 4.5 meters. The cumulative frequency graph gives information about the marks that 60 students got in a test. So we have got the cumulative frequency graph here, where the frequencies are represented on the y-axis with the highest frequency as 60 and the marks are given on the x-axis. For 60 students, the highest mark was 74 and the lowest was 8. So the highest mark for the highest frequency here is 74. So that's shown on the x-axis here. So this is the highest mark. And the lowest mark is from where the graph begins. So that's at 8. Now on the grid below, draw a box plot for the distribution of the marks. So we have to draw a box plot with the information given, and we need to figure out some more of the values. So to draw a box plot, we need to have a median. We need lower quartile, upper quartile, and the highest and the lowest frequencies are already given here. So starting from median, so median is the middlemost value. So if we take the highest frequency, that is 60, and find the half of its value, so 60 over 2 is 30. The median is at 30th position. Lower quartile is a quarter, represents the quarter of the data. So quarter of 60 is like half of 30. So median is half of the total frequency. So half of the median is lower quartile. That is 15th. So lower quartile is at 15th position. Upper quartile is 3/4 of the total data or the total frequency. So 3/4 is like you just have to multiply 15 by 3 because 15 is the quarter of the data. So I will do 15 times 3, that is 3 5 15 plus 1, 45th position. The upper quartile is at 45th position. Now taking these values from the graph, we need to figure out what actually are these what is the median, lower quartile, and the upper quartile. So starting from median for the 30th position, so I will go on the y-axis, find where 30 is. This is the position for 30th. So this is the 30th frequency. So make sure I'm drawing straight lines. So draw a line on the graph. So now its corresponding x value will be the median. Make sure you are as accurate as possible. Well, slight variation in your answer will be accepted, like a variation of one or two numbers up and down will be fine. But make sure you use a ruler and draw it accurately. So I'm getting the median at 34. So the median value is 34. So I'm getting the median 34. Lower quartile is at 15th position, so I draw a line at 15, so it's in between 10 and 20. So here, all the way here, and drop it on the x-axis. So that looks, it's at 26, 22, 24, 26. So I'm getting the lower quartile as 26. And the upper quartile is the 45th position. So this will be between 40 and 50. So here I draw a line on the graph and drop this line on the x-axis. So that is at 42. So I'm getting the upper quartile as 42. So with all this information now, I will draw the box and whiskers plot. So starting with median, which is at 34, I will use the straight lines again. So at 34, 32, 34 is here. So if I draw, make it proper. Sorry. 32, 34 is here. This looks better. And the lower quartile is at 26, 22, 24, 26 is here. So a line here. And the upper quartile is at 42. So that looks fine. And I will connect all these to make a box. Okay. And the the highest mark and the lowest mark should also be represented here. So the lowest is at 8, which is here. So my hand is shaking here actually. Okay, that looks fine. And 74 is here. And then I connect them. Not very good, but it's okay, fine. So I have drawn the box plot now. You can label them. You can label the median. This is the median at 34, or you have already shown the working, that's fine. It's always a good practice to label your points on the box plot as well. So this is median at 34. This is 34 median. And the lower quartile is at 26, is lower quartile. The upper quartile is at 42. 42 is upper quartile. And that's fine, I think. The pass mark for the test was 40. Sion says 30% of the 60 students passed the test. Is he correct? You must show how you get your answer. So the passing mark has a limit, like if anyone scores 40 or above, they will pass the test. Sian assumes that 30% of the 60 students passed the test. So we have to figure out if he is right. So we have to figure out if 30% of 60 students. So what is 30% of 60? So we know 10% of 60 is like 10% of 60 is 6. So 30% of 60 will be 6 times 3, that is 18. So 18 students are actually is, so 30% of 60 is 18 students. So if we can figure out if 18 students, so if 18 students scored 40 or above, then we can say his assumption is right. So how we can confirm this information from a graph? So for 40th mark, so let me use another color here. So for the 40th mark, this is the 40th mark, right? So if you drop a line here, let me use this. Okay. So if I draw a line all the way till the graph at 40 on the x-axis, then its corresponding y value will tell me how many students have scored 40 and above. So its corresponding value here is it looks like it's 42. Am I accurate here? So 40, 41, 40. Yeah, so this is at 42. So to get how many students scored above 40, you have to find the range from 60 to 42. So how many students are there in this range? So this range will have like 60 to 42. We will have 18 students, if for in more precise. Yeah, so there are 18 students between 60 and 42. So 18 students got 40 marks, 40 marks and above from graph, and we have shown that using this line, using the red line here. So this confirms Sian is correct. So we will finally write yes, Sian is right. Work out 25 power half times 8 power 1/3. So when you see these fractional powers, you need to know that these are either square roots, cube roots, or higher, so other roots. Okay, so precisely if there is a 2 in the denominator, that means it's a square root. So 25 power half is square root of 25. And 8 power 1/3 is cube root. The denominator is 3, so that is cube root of 8. If there is any number in the numerator, that goes as a power inside here. So since we have just one, so this is the these are the numbers we get, and these needs to be timed because that's the operation in between. So what is square root of 25? Well, as a reminder, I would suggest you to remember all square numbers and cube numbers, square and cube numbers between 2 to 20, or square numbers you have to remember between 2 to 20, and cube numbers you can remember from 2 to 10 or 15. If you remember all these numbers, such calculations in paper 1 will be really handy for you. So the square root of 25, so what number multiplies to itself to give 25? So we know 5 times 5 is 25. So square root of 25 is 5. So square root of 25, you can write it as 5 times. Now, what is cube root? So cube root of 8. Which number multiplies to itself 3 times to get 8? So again, you need to remember them. So if you remember, it's 2 times 2 times 2. That is 2 twos is 4, 4 twos is 8. So cube root of 8 is 2. And the final answer when you multiply them is 5 times 2 is 10. The answer is 10 here. The next question, find the value of 1 over 32 to the power of 3/5. So again we have a fractional power. So see the denominator, that is 5. So that means it's a fifth root of this number, which is 1 over 32. But we have got a numerator value as 3 also here. So where would that go? That will go here as a power. So fifth root of 1 over 32 power 3. Well, this is equivalent to saying fifth root of 1 over 32 whole power 3. This is another way of writing the same expression here, same term. Okay, so now we will focus inside the parentheses and figure out if we can simplify it. So 1 over 32. So I'm just focusing on 32. Is there a way I can split 32 so that I get a number power 5 is 32, so that I can cancel the fifth root and the power 5. So 32 is can be expanded and written as 2 times 2 times 2 times 2 times 2. That is 2 twos is 4, 4 twos is 8, 8 twos is 16, 16 twos is 32. So 2, that is 2 power 5. 2 power 5 is equal to 32. So I can replace this 32 in the denominator here with 2 power 5. So this can be written as fifth root of 1 over 2 power 5. Well, I can write this as whole power 5 because 1 power 5 is also 1. So 1 over 2 to the whole power of 5 is equivalent to 1 over 32. And don't forget to put this cube outside. Now inside the parenthesis we have a fifth root of half to the power of 5. So this 5 and this fifth root cancels out. So how does that happen actually? So it's as good as saying it's like 1 over 2 power 5, and fifth root is like again power 1/5. Fifth root is as good as saying the power is 1/5. So this 5 and this 5, because this 5 times, okay, let me write it more clearly here. So this is like saying half power 5 times 1/5, because these two are in powers. So they cancel out to make the power as just 1. So that's just half. So I can cancel them and you get 1 over 2 finally, but with the power of 3. So half cubed means you have to do half times half times half, which is equal to 1 over 8 as the final answer. Kate was asked to factorize x squared plus 5x plus 6 in the form x plus a times x plus b. So this is like the factored form of this expression. Kate says the sum of a and b must be 6 and the product of a and b must be 5. Explain what is wrong with Kate's statement. So if we are representing an expression in the factored form, what are we doing actually? Or if I go the other way, if I try to expand this factored form and get back in this expression, let's see where are we adding or how are we actually manipulating these terms. So we multiply every term here to expand these parentheses. So x times x is x squared, x times b is xb plus x times a is ax plus x a times b is ab. So this can be further simplified too. We can take the like terms together. So we've got x square as the first term, and the like terms, if I take the common like term, which is x, then I get a plus b, and the final term here is ab. So here we get to see that a plus b, the numbers a and b are getting added, and they actually act as a coefficient to the middle term x. So the middle term x has got the coefficient, which is which you get by adding these two numbers a and b, and the final constant term you get by multiplying a and b, that is the product of a and b. Okay, so but this Kate says that the sum of a and b must be 6 and the product of a and b must be 5. She's saying the reverse thing, she's saying the opposite thing. So what is wrong with her statement? Well, we get a plus b, so we add a plus b to get 5, the coefficient of the middle term, which is the coefficient of middle term, that is x, and a times b, that is the product of a and b, you get by, so that is the final the constant term, which is 6. So this is the this is the right statement, so she is doing the other way. Okay, so that's wrong with her statement. Factorize fully 2m square minus 2. So to factorize these two terms, we take out the common number here, that is 2. The HCF of 2 and 2 is again 2. So we take out the HCF and we will write the remaining terms. So if you, to know what remains here, 2m square divided by 2 is just m square. 2 divided by 2 is 1, and there is a minus sign here. So that goes inside the parenthesis. Now this can be factorized further using the difference of square formula. So what is difference of square formula? So if something is like in the form a square minus b square can be factored as a plus b times a minus b. So for that you need to have these two terms also as squared numbers. So here we see m is a squared number, and 1 is can also be considered as a square number because 1 square is again 1. So I can write this as 1 square. Now m square minus 1 square is of the form a square minus b square, which can be factored further as a plus b times a minus b. So in our case it will be m plus 1 times m minus 1, and there is a 2 here. So now we have factorized this expression fully. The final answer is 2m plus 1 times m minus 1. Factorize fully ax plus bx minus ay minus by. So you see there are like terms here. If we consider the first two terms together and the last two terms together and factorize them separately. So ax plus bx, you can take out x terms as common here, which is x. If you take out as common term between ax and bx, then we have a plus b remaining. And then from the last two terms, if you take out y as the common term, or precisely because these two are having like negative sign, so if I take out minus y as common as a common variable, then we have a plus b remaining inside the parenthesis. So now we see there are two terms here, which has got a plus b as a common term again. So a plus b can be taken out further as common. So if I take out a plus b as a common term from these two terms, then what is remaining? So if you take out a plus b from this term, we have only x remaining. So if you take out a plus b common from this whole term, we have y remaining with a minus sign here. So now I have factorized this expression fully as a plus b times x minus y. This is one way of doing it. We can do it alternately uh, with a slightly different approach. I mean, it's the same thing, but just the variables or the letters which you are taking as common can be slightly varied here. So if I, instead of taking x as common, if I take the letter a as common from this expression, then a is taken as a common, then what goes inside the parenthesis? So I am assuming this and this letters, this and these two, this and this term. So from these two terms, if I take out a as a common term, then I have x minus y remaining inside the parenthesis. And then if I take out b as a common from these two terms, so plus b, because there is plus b here, then what remains inside the parenthesis is again x minus y. Now I have these two terms. First term is a times x minus y, and the second term is b times x minus y. From these two terms, I see x minus y is a common term which can be factorized further. So if I take out x minus y, what remains now will be a in the first term and b in the second term with a plus sign in between. Now you see the answer to both these approaches is same. So you can use any of these techniques, whatever you find easier. So I'm going with the answer x minus y times a plus b. A, B, and C are three solid spheres. Sphere A has a volume of 64 centimeter cube. Sphere B has a volume of 125 centimeter cube. The radius of sphere C is 50% of the radius of sphere B. Work out the ratio of the sphere surface area of sphere A to the surface area of sphere C. Give your answer in the form A to B, where A and B are integers. So we have got three different spheres, A, B, and C. Now we have the volume of sphere A and B given as 64 and 125 centimeter cube each. So this is the volume given. We don't know anything about the radius of any of them, but from the volume, using the scale factor, so if volume scale factor, if the radius is like r, then the volume scale factor will be like r cube. Or if you go the other way, if the volume is r, then its radius will be cube root of r. Similarly for surface area, so for area, scale factor is r square. So if you go the other way, if you have the area, to get the radius or the length, use square root that area. Or if you have the length or the radius, then you get the area by squaring it. So we have got these relation. So using the scale factor thing, we can try to answer our question. So the volume for sphere A and B can be written as a ratio of 64 to 125. So from volume, I can figure out the radius of these two spheres by using the volume and the radius connection here is, like if I do cube root of 64 and cube root of 125, then I get the radius of spheres A and B. So now what is the cube root of 64? Again, as a reminder, I'm telling you, if you remember all the square numbers and cube numbers, such calculations will become easier for you. So 64 is which number multiplies to itself 3 times to get 64. We have 4 times 4 times 4 gives you 64. So the cube root of 64 is 4. And 5 times 5 times 5 gives you 125. So the cube root of 125 is 5. So we got the radius for spheres A and B in the ratio 4 to 5. There is this information which says the radius of sphere C is 50% of the radius of sphere B. So there is the connection between the radius of spheres B and C, that this sphere C has radius is 50% of the radius of sphere B. That means 50% means it's like half of the radius of B. So if the radius of B is like 5 units, then radius of C will be 2.5. It's half of it, right? But since the answer needs to be in the form of integers, I want to get rid of this decimal value, so I can scale up this ratios. So if I double them, so if I double 2.5, I can get rid of this decimal. So if I scale up, I need to scale up the entire ratio. So if I do this times 2, then this will be 2.5 times 2 is 5. Double of 2.5 is 5. Double of 5 is 10. Doubling 4 gives you 8. Now I get this as a ratio for the radius of A, B, and C. From this ratio, you actually have to find the ratio of surface area of sphere A and sphere C. So you have to find surface area. So we have got the radius, we have to find the surface area. So again, using the scale factor, if you've got the radius, to get the surface area, you use the scale factor like r square. You just square these terms, okay? But we need to only find the surface area for spheres A and C. So we are just using these two values. So square, so it will be 8 square and 5 square. So 8 square is 64, 5 square is 25. So the final answer is, so it wants it as a ratio, right? So answer is 64 to 25. Here are two cuboids. All lengths are measured in centimeters. The volume of cuboid A is 142 centimeter cube, greater than the volume of cuboid B. Work out the value of x. We have got two cuboids A and B with the dimensions given in terms of x. They are expressions. We have to figure out what will be the value of x here. So we can start from cuboid A. So volume of cuboid A on the as an equation. So as an expression on the left side, I will begin. How do you get the volume of a cuboid? Well, you just have to multiply each dimension. So the length here can be taken as this side. So if it's 2x minus 1, so length times width times height gives you the volume of a cuboid. So length is 2x minus 1 times width is x minus 1 times the height is x plus 2. If I multiply them all together, they I have to solve that algebraic expression to find the volume of cuboid A. So this is just an expression. I will do the similar thing for cuboid B and try to see if I can connect them using an equation with the information given here. So we have this information that volume of cuboid A is 142 centimeter cube, greater than the volume of cuboid B. So whatever the volume of cuboid B we get, volume of A is 142 more than the volume of B. So let's first figure out an expression for volume of cuboid B. Similar way as we did for A. So length times width times height. So here we've got the length is 2x times width is x minus 3 and the height is x plus 3. This is the volume of cuboid B. Now there is this connection that A's volume is 142 more than B's volume. So that means this volume is 142 more than this volume. Or if I add 142 to the volume of B, that will be equivalent to volume of A because volume of A is larger than volume of B. So now I have made a proper equation here, which is in terms of x, and there are a lot of expressions involved here. So we need to first expand these parentheses, simplify them, and see what we can do with the value of x here, and see how can we get the value of x. So starting from left side, I'm just focusing on these two expression. I mean these two values, expressions here. So if I'm taking these two parentheses, so using the FOIL approach, multiplying out each and every term here, so I get 2x times x gives me 2x square, 2x times 1 but with a negative sign, so 2x times negative 1 is negative 2x, is minus 2x, and minus 1 times x is minus 1x. Minus 1 times minus 1 is positive 1. So before moving ahead to multiply it with this parenthesis, I would like to simplify it here itself because I can see there is these like terms minus 2x, minus 2x, minus 2x and minus x. So which can be written as 2x squared minus 3x plus 1. And then I will take down this x plus 2. Now again following the same thing, I will multiply out everything here, this with this with this term, this with this, and this with this term, and this two will be multiplied. Starting from here, 2x squared times x will be 2x cubed. 2x squared times 2 will be 4x squared. Then minus 3x times x will be minus 3x squared. Minus 3x times 2 plus 2 will be a minus 6x. And 1 times x will be just 1x. So did I miss out anything? So I did this and this and then this, then 3. Oh, I did. So this is 3x squared, 6. Then 1x. Yeah, I have to write the final term 2 here. So and then I can simplify it using the like terms. I can see these two are like terms and these two are like terms. So 2x cubed, 4x squared minus 3x squared is just 1x squared, minus 6x plus x. So minus 6x plus x, that is taking 1 from 6, you have minus 5x plus 2. Now this is equal to, now I will do the same thing with this part of the expression here. So ignoring 142 for a while, I'm just focused on these three parentheses. So starting from these two, so 2x and this, I will have 2x squared, 2x times 3, that is negative 6x, right? And then there are no like terms here, so I can go ahead and multiply to the third parenthesis here. So I multiply this with this with this, and these. So 2x squared times x is 2x cubed. 2x squared times 3 is plus 6x square, then 6, so that's minus 6. Minus 6x times x is minus 6x square. Minus 6x times 3 will be minus 18x. So let me recheck if I did it all right. So 2x cube, 2, 3 is 6x square, minus 6x square, and 3 is, yeah, that's right. So I will write this down here now. That is equal to, now I'm taking this 142 and plus 2x cube plus 6x square minus 6x square minus 18x. Now, is there anything I can simplify further before moving on to bring all the like terms on either side of the equation? Well, I see there is plus 6x square minus 6x square, which cancels them and makes this part x square coefficient as 0. So I can cancel it right away here. And also we see there is a 2x cube and a 2x cube here. So if I bring them together on one side of the equation, they actually cancel out. So we can cancel this as well. So now what remains is x square minus 5x plus 2 and minus 142. Because I subtract 142 on both sides, I get minus 142 and plus 18x. That is equal to 0. Now I can take the like terms here on this side. So 18 take away 5 is 13x, so that's a positive. So plus 13x, and 2 take away, so from 142 will be a negative 140. This is equal to 0. So now I have arrived at a quadratic equation. So I will write the constant term here. To be precise, it's minus 140. Then figure out if I can express this number as some factors, so that when I subtract them, I get this coefficient of the middle term. So what are the factors? Well, we have got many factors of 140, but we will choose something which will be of some. So 70 times 2, well, it's not useful to me. I can use 7 times 20, I think. Yeah. So if I take away 7 from 20, I get 13. So to be precise, it should be minus 7 and plus 20 to get a positive 13, right? So I've got the factors. I can write this quadratic expression in the factored form by taking x minus 7 plus 20 equals 0. Now this is a quadratic equation in the factored form. That means either x minus 7 is 0 or x plus 20 is 0. So if I take them individually, if x minus 7 is 0, then the value of x is positive 7. Or if x plus 20 is 0, then the value of x is negative 20. Now we have this constraint here that we are talking about cuboids and the lengths and the dimensions. So we avoid taking the negative value here. So the only answer we get is the value of x is 7 here. ABC is a triangle. Work out the length of AB. So, well, this looks like it's not a right triangle, so we cannot use the trigonometric ratios or the Pythagoras theorem here. So we are left with these options. We can either use the sine rule or the cos rule here. So we can go with the sine rule because we have been given two of the angles. One of the side is given and we are asked to find the length of AB. That is, we have to find this side AB. Okay. So I think we can use a sine rule here. so that goes well. So if I'm so I'll begin with the labeling of the angles in the sides so that my it becomes easier for me to use the formula. So we have got the angle A here, and the side opposite to that will be the small a. The side opposite to this angle C is C. The side opposite to B will be B, right? So, well, we are not in any way, um, we don't need this A and A. We are not using that. So we just are concerned about these two angles and these two sides. So we can use the sine rule here with these B and C as the sides and the angles. So it will be B over sine B equals C over sine A, right? Sorry, B C over sine C. So this is small c actually. Let me rewrite it again. This is C over sine C. Okay. Now substituting the values here, what is B? B is 3 root 2, 3 root 2 over sine B. Sine of the angle B is sine of 30. Angle B is 30 degrees. C? C is missing and we are figuring out what is the value of C over sine C. C, the angle C is 45, so that is sine of 45 degrees. Now to find C, we have to make C as the subject of our equation. So we times with sine 45 on both sides. So this times sine 45. So I get rid of this. I have only C remaining on the right side. So on the left side, we've got sine 45 times 3 root 2 over sine 30. Well, again, I would write it as a reminder to remember sine, cos, and tan values, or these ratios you need to remember for the angles 0 degrees, 30 degrees, 45 degrees, and 60 degrees. Actually, there's a table, you need to remember those values. Uh, so, so such calculation becomes easier for you. So I will write it down here. So sine of 30 and sine of 45. The value of sine 30 degrees is a half. Sine of 45 is 1 over root 2. Okay, so now substituting these values here, sine 45 is 1 over root 2. I will write 1 over root 2 times 3 over root 2, 3 times root 2 over sine 30 is half. Now how can we simplify this? It looks a bit weird. Well, you don't have to worry about that. So I can write it in a little better way. So half 1 over root 2 times 3 root 2. Now there is a denominator which has a fraction. So actually this can be written in the, so this can be brought here and written in the numerator by making it as its reciprocal. So the reciprocal of half is just 2. So I can write it as 2 here. So now this looks much better. Uh, Again, we can simplify. There is a root 2 here and there is a root 2 which are like multiplication signs in between. So I can cancel them together. Now what is remaining? 1 times 3 times 2, that is 6. So the value of AB, the length AB here is 6 centimeters.